Hey guys, today we are going to do our last couple of strategies for solving a quadratic. We are going to quiz on all of these on Wednesday, so we will review together on Wednesday and you'll do a quiz. I'm going to give you the review today, so that way you have a couple days to work on it, and then we'll answer any questions about the review on Wednesday, and then I will let you take the quiz. All right, go ahead and get out your homework from last week. We're going to grade that here in a minute. Today, those last two strategies, we're going to solve by using square roots, and we're going to solve by completing the square. And our essential question today is, how can you complete a perfect square trinomial into the square of a binomial? Okay, so first let's check our homework. Here are the answers 1 through 20. We're going to do the rest of those today, so make sure you keep that sheet out. So check your answers with mine. If you have any questions about any of these, you can send me a message and I can go over any of them with you. So pause. All right, let's go ahead and start off with a warm-up. Let's remember how to factor. This first one, solved by factoring, okay? What I see first before anything else is that it's not equal to 0. So I'm going to make it to equal to 0 first by subtracting 33x over. And when I do that, I got to put it in the right spot, which is going to be in the middle. So it'll be 3x squared minus 33x. And then plus 72 equals 0. All right, from here, I see that my a value is a 3. Before I do slip and slide, I'm going to see if I can actually divide the whole thing by 3. So 33 can be divided by 3. 72 can also be divided by 3. It equals 24. So this one has a GCF. So we're going to move a 3 out. We're left with x squared minus 11x plus 24 equals 0. Doing that, now we just have basic factoring. So we think to ourselves, what is going to multiply to give me positive 24, to add to give me negative 11? 24 has a plus sign, so they're both going to be the same sign. 11 is negative, so we know they both have to be a negative number. And those numbers are going to be 8 and 3. So this factors to be x minus 8 and x minus 3. Okay, I have factored my problem, but now I need to actually solve it, meaning I'm going to take each piece, make it equal to 0, and solve for x. So if I have x minus 8 equals to 0, I'm going to add that 8 over and get x equals 8. Here, x minus 3 equals 0, add that over, we're going to get x equals 3. So here my two solutions are going to be x equals 8 and 3. Remember, we talked about what that means. That means if I were to graph this quadratic, it's going to cross the x-axis where x is 3 and where x is 8. So it would look something like that. All right, let's do another one. Solve by factoring. Again, I see that this equation is not equal to 0, so I'm going to move everything over. We want it in standard form, so it should look like this. So I'm going to add 18x over, and I'm going to add 9x over. That leaves 0 over there. These both have an x, so this is actually going to be x squared, what is that, plus 27x equals 0. All right, well, this is interesting. I do see that they both have an x, so I'm going to take the x out. I'm left with x plus 27 equals 0. Okay, so the only factoring I really did was I factored out a GCF. I'm done. There's no more quadratic, so we're going to take each piece and make it equal to 0. So I'm going to have x equals 0. Okay, well, that part's done. And then my parentheses, x plus 27 equals 0. Subtract 27 over. And this one gives me x equals 0 and x equals negative 27. All right, so that one was a little different, but it's good to see different. because you never know what's going to show up. All right, so let's get going on today's lesson. We are going to explore solving by using the square root first. We are going to use this method when the b value is missing. So in my standard form, if my b value is missing, that means there was a 0 in its spot. Okay, that should be an x right here. That should say 0x. So my b value, which is this guy, my b is 0. Whoop, go back. So we have ax squared plus c. So we have something squared than just plus a number. All right, the steps we're going to take, we're going to isolate whatever variable is being squared. So it means we're going to have to add or subtract that c out of the way. And then we're going to have to divide by the a value if there is one. Then after that, we are going to square root both sides. Remember, when we square root something, we should always get 2 answers, okay? Because 5 times 5 is negative 5. My gosh. 5 times 5 is 25. Negative 5 times negative 5 also equals 25. So we should get 2 solutions, a positive and a negative, when we square root something. Okay, here we go. 4x squared plus 10 equals 46. All right, so I'm missing a b value, right? And there is no coefficient attached to just an x. So these are going to be solving with square roots. I need to isolate the x squared. That's this piece. I need to get it by itself. So to do that, I'm going to subtract 10. So I have 4x squared equals, what is that, 36. All right, I still don't have x squared by itself. I have to move my a value by dividing it because right now it's being multiplied. So divide both sides by 4. We're going to get x squared equals 9. Step 2 tells me once it's by itself, I can square root both sides. So when we do square root here, the square root of 9 is positive and negative 3. So that is 2 answers. It is 3 and it is negative 3. Okay, that's how this shows that you have the positive and negative of the same thing. All right, my other side. 3x squared plus 5 equals negative 25. Okay, well, here's the variable that's being squared. My first goal is to get that by itself. So I'm going to have to subtract the 5 and I'm going to have to divide by 3. So we're going to subtract 5 first to give me 3x squared equals negative 30. Then I'm going to divide both sides by 3. And we have x squared equals, what is that, negative 10. All right, now that it is by itself, I can square root both sides. Okay, well, the square root of negative 10, remember, that's negative 1 times 5 times 2. What does the square root of negative 1 turn into? It turns into an I. I can't break apart 5 and 2 anymore, so that's going to stay 10. And remember, we are going to have the positive and the negative of each answer. So we have positive and negative I times the square root of 10. Okay. We got 2 more. I would like to pause, actually. I'm going to show them to you. I would like you to please pause the video, and I want you to try these on your own and then push play and see if your answer matches mine. So go ahead and push pause. All right, check your answers with mine. For the first one, you should have gotten positive and negative square root of 5. And for the second one, you should have gotten positive and negative I times the square root of 2. Okay, all of these answers will have a positive and a negative in them. All right. Next, still using square roots. These look a little bit different because I don't have just a variable being squared. I kind of have a whole bunch being squared. All right. So in this case, when I look at x minus 3 squared, minus 7, essentially the piece that's being squared is already been isolated. This is already by itself. Nothing else is being added or subtracted. So that means I can go straight to the step of square rooting both sides. All of x minus 3 is being squared, so all of x minus 3 is going to get square rooted. When we square root a square, they cancel out. So doing that, x minus 3 is free. It got broke free. But my other side is going to be positive and negative square root of 7. Remember, our square roots are going to give us a positive and a negative. From here, x is not by itself. We're going to add the 3 over. So when you do that, remember our constants always go in front of our radicals. So we are going to get x is equal, my constant is 3. Remember, we have positive and negative square root of 7. So you're actually you would do 3 plus square root 7, and then you would do 3 minus square root 7. So that shows that you have two answers. 3 plus square root 7 and 3 minus square root 7. Those are two different numbers. I'm actually going to type it in and see what it is. 3 plus square root of 7, so that's like 5.65-ish. 3 minus the square root of 7 is 0.35. So two very different numbers. We're going to always leave it in radical form. I never want decimals, okay? But I'm just showing you here that they are two different numbers. Okay? So I want to pause, and I want you to do the next one. So go ahead and pause. All right, check your answer with me. Square root both sides, because I already have x plus 5 being squared, or I can't move anything over with those parentheses. So when I square root both sides, x plus 5 is now free. The square root of negative 4, though, because of that negative, that's saying the square root of negative 1 times 4. The square root of negative 1 is I. The square root of 4 is 2. And remember, we're going to have the positive and negative each. So that's going to be positive and negative 2i. Remember, we always do the number first. Then subtract 5. Constants stay out front. So your two answers are negative 5 plus 2i and negative 5. Ooh, that should be a minus. And negative 5 minus 2i. Which, again, you can write it like this as a conjoined solution. Because this symbol right here means to add and also to subtract. Okay? We are about to move on to our next section, which is going to be solve using complete the square. Some of you may have used this before. It might just be a while since you've done it. Okay, so with complete this square, what we're going to do, we have an equation, okay? It usually cannot be factored, okay? Nothing multiplies to give me 3 and adds to give me 6. It's not possible. Quadratic formula, always possible. I could do that with this, but I'm not going to. Instead, we're going to complete the square. The reason why I'm going to do complete the square is because this has some key features that I like. I like that the a value is technically a 1, and I like that my b value is an even number. So I have an even b, and I have an a equal to 1. These are great key features to use for complete the square. Okay, so I have the steps over on the left hand side. Step 1 is to move c to the right by itself. So our c value here was negative 3. So the very first thing you do is you're going to move the c to the other side. So here I'm going to add the 3 over. Okay, when you add the 3 over, you're going to leave a blank where it was, and you're also going to add that same blank on the other side. Because my next step, we're going to take b, we're going to half it, square it, and add to both sides. So I've left a gap for that. So remember, my b was negative 6, right? So it said to half it, so that's negative 3, and then square it, that is 9, and then add it to both sides. So I took my b, which was negative 6, I cut it in half, which gives me negative 3. I squared it, so negative 3 times negative 3 gives me 9. You add that onto both sides. It should always be a positive number. All right, now we can rewrite the left side as a perfect binomial squared. Okay. And we're going to simplify the right side. 3 plus 9, that is 12. All right, perfect binomial squared. What does that mean? That means the same number times itself gives me 9, and this same number added to itself is negative 6. Okay? And technically, you have already found this number. The number is what you get when you take your b and cut it in half. So it's going to be x minus 3. Think about it. Negative 3 plus negative 3 is negative 6. Negative 3 times negative 3 is positive 9. So this is a perfect square trinomial, and I reduced it down to what the perfect binomial is being squared. All right, so now this resembles the problems that we just did. We need to solve for x using my theory or my strategy that we just worked with. So it is already, I have a parentheses being squared. So to undo that, we're going to square root. If I do it to one side of my equation, I have to do it to the other side. So here I have x minus 3. On this side, we know we're going to have a positive and negative something, right? Because we took the square root of a number. 12 breaks apart to be 4 and 3. So that's going to be 2 square root of 3. Because the square root of 4 is 2. We're almost done. Now we're going to add 3 to the other side. 3 is a constant, so it's going to be out front by itself. And then we're going to add and subtract our radical expression next to it. So our two solutions for this one will be 3 plus 2 times the square root of 3 and 3 minus 2 times the square root of 3. Okay. Remember, that is technically two different answers. Okay, these are numbers. We're just writing them in radical form. You'll always write them in radical form. If you ever give me a decimal, I'm going to count it wrong, so don't do it. All right? Let's try the next one. We have x squared minus 8x plus 7 equals 0. So again, I see that I have an a value of 1. I have a b value that is even, so I like this, so we're going to use complete the square. So step 1, move c to the right. My c here is positive 7, so we're going to move it over by subtracting it. I'm going to remember that when I subtract it to leave some blanks. That's how you're going to actually complete the square, is by adding that very specific number to both sides. The number we are going to use is we're going to take my b value, so that's negative 8. We're going to cut it in half, so that gives me negative 4. And then we're going to square it to get 16. So 16 is what's going to be added on both sides. All right, we're going to rewrite the left side to be a perfect binomial squared. Okay, so remember the same number multiplied to itself was 16, added to itself is 8. And remember, you found it over here when you took b and divided it by 2. So it's going to be x minus 4. My other side, negative 7 plus 16, that actually simplifies to 9. So we simplified each side. Now we're going to solve using what we did before. I see I have a parentheses squared, so to get rid of that, we're going to square root both sides. My x minus 4 is now free. I took the square root of a number, so I don't have positive and negative of something. Well, the square root of 9 is 3. That was nice and pretty. Now we're going to get x by itself by adding 4 over. So this becomes 4 plus and minus 3. Okay, well, this isn't radicals. I can actually do that. I can do 4 plus 3, and I can do 4 minus 3 to give me my two x's of 7 and 1. So my two factors here were 1 and 7. So fun fact, at the very beginning of this, I could have factored it. It's possible. Basic factoring can work with this problem. But if the directions tell me that I have to do complete the square, then I have to show that I know the skill of complete the square. Okay. I got two more for you. X squared minus 4x plus 6. All right, so again, I notice A is 1. I have an even B. It's negative again. Goodness, are they all negative? Okay, no, the next one's not. All right, here we go. Move C to the side. My C is 6. We're going to subtract it over. X squared minus 4x, leaving that blank. Over here, negative 6. Keep the blank. To fill in my blank, we take our B value, which is negative 4. We're going to half it to get negative 2. And then we're going to square it to get positive 4. So we're going to add 4 to both sides. All right, we're going to simplify and rewrite. So here, negative 6 plus 4, well, that's negative 2. All right, my perfect square binomial is going to be what is multiplied to itself to get 4, added to itself to get negative 4, and that number we get by taking b and dividing it by 2. Our number is negative 2. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. All right. Parentheses squared, we get to square root both sides. So x minus 2 is out. Equal, I took the square root of a number, so I'm going to have a positive and negative of something. Negative 2 is negative 1 times 2, so we're going to have I square root 2. So my I got to come out because of the negative 1, but square root of 2 does not simplify, so the 2 stays inside. Now we're going to add 2 to both sides. Remember, my constant stays out front, so we have 2 plus and minus I square root 2. Now, bonus question, what does that mean about these solutions? They're imaginary, right? So what does that mean about how they're going to look on a graph? They're not going to touch the x-axis. They're going to be floating somewhere, maybe above, it might be below, okay? But it is not going to touch the x-axis. Okay, one more. (6x squared plus 12x minus 90). Well, what? My A is not 1. My B is even, though. I don't want to slip and slide. Well, the directions tell me I have to do complete the square, so I have to do it. This one has a GCF. So if my directions tell me to use complete the square, I got to make that A value a 1. So here I can divide each piece by 6. So we have x squared plus 2x minus, oh, what is that? 90 divided by 6 is 15. Okay, now we can complete the square. When you do complete the square, leave 6 out of it, okay? We don't need it. It's just going to be part of my answer later, and we'll talk about what it's going to do for my solutions. But when I complete the square, the 6 is not needed because the 6 didn't have an x. So honestly, the 6 isn't even going to give me a solution, right? I have to solve each piece with an x equal to 0. 6 does not have an x. So I can actually just ignore it from now on. Took it away, don't need it anymore. What I have left, though, I'm going to add my c value over, because my a is 1 now. We have x squared plus 2x plus whatever's missing equals positive 15 plus what I'm going to... The filling in the blanks is completing the square. It's completing the equation, okay? Because the square, this turns into a perfect square, right? I don't know what that is until I complete it right here. All right, take my b value, cut it in half, we get 1. Then we're going to do 1 squared to get 1. So we're going to add 1 to both sides. 15 plus 1 is 16. Over here, multiplies to itself to get 1, adds to itself to get 2. Remember, that's the same number when I take b and cut it in half. So this time I have a positive 1. So x plus 1 squared. All right, there's a parenthesis being squared, so we're going to square root it. Square root both sides. My x plus 1 breaks free. I'm taking the square root of a number, so I know it's positive and negative something. What is the square root of 16? It is 4. Oh, this is nice. When I subtract my 1, it comes out front. Negative 1 plus and minus 4. I can actually do that. Oops, sorry. So negative 1 plus 4 gives me what? A positive 3. And negative 1 minus 4 gives me negative 5. So those are my two x values. So we get 3 and negative 5. So this parabola would cross the x-axis where x is 3 and where x is negative 5. Okay? Time to practice. So the worksheet from Thursday, you are now doing the last 10 problems, 21 through 30. Please fix number 28 or you can't do it. There was a 9 and 3 there. They were in the wrong spots. So please on number 28, change it to 3m squared plus 18m plus 9 equals 0. All right. Good luck.